Hello, everybody. We are back to work on some math. We're going to do section 8.4. Sorry, I'm totally lying. We're going to do section 9.4 on page 372. More exponents, so let's give it a try. Page 372, lesson 9.4. Go. Okay, that's all I have for you today. Hope it goes well. No, of course, I'm just kidding. Let's turn to page 372, example 1. Before we do any examples, a couple things I want to point out to you. The first one is right here on the top of the board. 4 to the 0 power. Okay, and this is shown at the top of page 372. Any number to the 0 power, the answer is 1. And you can move on. 5,462 to the 0 power is just 1. So you write a 1 and you go on. Those are going to be your favorite problems because all it is 1, move on. All right, so anything to the power of 0 is the number 1 as your answer. Okay, the second concept we're learning new today is this. If you have a negative exponent, which I don't think you've seen before, no problem. What you do is this. If you have a negative exponent, what you have to do is you have to move it and make it positive. So right now, if I put this over 1, that's a fraction, right? So if I'm going to need to move that negative exponent to make it positive, we just have to move it to the bottom. Right now it's on the top of my fraction. I'm just going to move it to the bottom. And when I do that, it becomes a positive exponent. So the way to make it positive is super easy. You just have to move it. If it's negative and it's on the bottom, move it to the top. If it's on the top, move it to the bottom. So mine was on the top when I made it a fraction, so I move it to the bottom. Empty space gets filled with a 1, and now we can carry on with what we were doing, okay? So now you could do 1 over whatever 4 squared is, which is 16. Okay, so if you have a negative exponent, just move it to the opposite position, and it becomes a positive. But then you still have to go ahead and do the mathing part of it, okay? So let's look at example number 1. 3 to the negative 4 power. 3 to the negative 4 power. Okay, I'm going to put it over 1. Oops, I have a negative exponent. What do? Right now it's upstairs. We're going to move it downstairs, and it's going to become positive. The only thing that happened is that exponent became positive when I moved it. Nothing else. We still have to math the whole thing. Empty space gets filled with a 1. 1 over whatever 3 to the 4th is, which is 81. And I'm done. Let's look at example B. Negative 8.5 to the power of negative 4. Remember, it's really important to keep those parentheses. I've talked to a bunch of you about the parentheses. If you have a negative number, we got to keep those parentheses. Otherwise, we won't do it correctly. Okay? So we're supposed to also, it says, times it by 8.5 to the, negative again, to the positive 4th power. Okay. Are these bases the same thing? Let me erase this so we're not confused. Are these bases the same? They are. So when the bases are the same, remember, I can just continue putting that base and add my exponents, right? What's negative 4 plus 4? 0. What's anything to the 0 power? 1. Yay, we went from craziness to 1. Glorious. All right, so let's look at example C. 1C. 1C says 2 to the 6th over 2 to the 8th. Yesterday we learned that we're supposed to subtract those. So I'm going to take my base number and I'm going to subtract the exponents. 6 minus 8 is negative 2. Uh-oh. Do we like to have a negative exponent? Well, you might like it, but we're not supposed to. So what do I do when I have a negative exponent? I put it over 1, I move it, if it's up, I move it down, and it becomes positive. Empty space gets filled with a 1, and then I go ahead and solve my problem. 1 over 2 squared is 1 over 4, and I'm done. So let's review. I subtract my exponents, we learned that yesterday. That's a negative 2. I'm not supposed to have that. So I'm going to put it over 1. I'm going to go ahead and move it so that it becomes a positive, and then I'll complete my problem. Okay, just little steps. So just write them all out if you need to, because sometimes if you try and do it in your head, you miss one of the steps. So if you need to, write it all out like I do, no problem. keeps you clear of what's happening, okay? Let's look at example number 2. Example number 2. A, page 373. Negative 5x to the 0 power. Now this is another example of what those parentheses mean to us. There are no parentheses here. That 0 only applies to what it's right next to, which is the x, okay? So it doesn't apply to any of this because it's not in parentheses. It only applies what it's right next to. So anything to the 0 power is the number 1, even if it's a variable. So we have negative 5, and then it's supposed to be times, right? Because they're right next to each other, by whatever this is. Well, x to the 0 power is simply the number 1. Anything to the 0 power is just the number 1. So now I have negative 5 from this part, because nothing happened to that yet, times 1. Well, negative 5 times 1 is negative 5. Okay, let's look at B. 9y to the negative 3 over y to the 5th. I think I wrote that down right. Yes, okay? Okay, so we have a 9 right here. And then we have, so we dealt with that. I wrote it down. We still have it. We haven't done anything with that yet. Here I have a matching base. So remember, when you have a matching base and it's a division problem, you're supposed to subtract the exponents. Be very careful with your details here. Negative 3 minus 5 is what I should be doing, right? Okay, and it only applies to the y's because that's what it's right next to. There's no parentheses. So the 9 remains the way it is. We use the exponent for the letters only because there's no parentheses. So I went ahead and did negative 3 minus 5 because I'm supposed to subtract. We learned that yesterday. And that's where I'm at so far, but I'm not done. Let's go ahead and continue working. What is negative 3 minus 5? Negative 8. Okay. We're almost done, but we're not quite done yet because I'm not supposed to have a negative exponent. And what am I teaching you today is what to do with that negative exponent. So to get rid of a negative exponent, we've talked about them. Anybody have a guess? Okay, you're going to move it, right? Now, that negative 8 only applies to the y. It does not apply to the 9 because it's not in parentheses. I'm hoping you understand that. If you're not understanding that, please call me so I can explain that because it's really, really, really important, okay? So I'm going to show you a difference real quick. If it looked like this, that negative 8 would apply to the 9 and the y. But because there's no parentheses, it only applies to what it's right next to, okay? So let's go ahead and put it in our fraction. Now, it's a negative exponent, and to get rid of that, you have learned today that you move it. Okay, but the 9 doesn't have an exponent, so it stays. The y is the one with the exponent, so it's the one that moves. And I can change the exponent to a positive, and I can't simplify anything, like there's no fraction to simplify, like a 2 over 4 or something like that. So I can be done right like that, and that would be my answer. Why didn't the 9 move? The 9 did not move because only the y gets the negative 8. Okay, so be really careful with those details because they'll make a big, big difference in your answer. Okay, lastly, let's look at example number 3. Conversions. Oh, some of my least favorite, to be honest, mathing thing is conversions. But if we use the fractions, we can get to it. So I wrote some of it down already just to save me some time. So let's look at our problem. Example number 3, a drop of water leaks from a faucet every second. How many liters of water leak from the faucet in an hour? Well, underneath the picture, you can see how many liters are in one drop of water. So we need to know how many liters in an hour. And what we have is liters in a second, right? So first thing we're going to need to convert is going to be our hours to seconds. And some of you might be able to do this really easily, but I wrote it down here for you if you don't know the conversion. 1 hour, remember I used my conversion fraction right here, 60 minutes over an hour, and then I have to change minutes into seconds, so I did it another conversion, and I got a total of 3,600 seconds in 1 hour, okay? Because we multiply by 60 and multiply by 60 again. Okay, so 3,600 seconds in 1 hour. So now, since I know there are 3,600 seconds in an hour, and I know that 50 to the negative 2 liters happen every second, I can just multiply these, right? If I know how many seconds I have and how much, I think it's 50 to the negative 2, and I know how much comes out every second, I can just multiply those to figure out my total, correct? Now, I cannot have a negative exponent, although I'll tell you a secret. You can probably do it in your calculator and it will work. Try it. Okay, so for this word problem, you can try it. But when it comes to these problems here, I need you to do them out by hand because I need fraction answers, okay? So I'll show you how to do this. 50 over 1, I make it into a fraction. I can do that one into a fraction too. Remember, I cannot have a negative exponent, so the 3,600 stays, but I have to move this downstairs, right, so that it becomes a positive. Okay, so I moved that one down so it becomes a positive. Now I multiply across the top, I multiply across the bottom. I get 3,600 here, and 50 times 50 is what, 2,500 here? And then I think I can divide, as they'll be happy to have a decimal here. Let's look. Yep. So I divide that and I get 1.44 liters of water per, what were we dealing with? What did we change it to? Hour. I think you can still see that, yes. Kind of a long problem. Sorry. But there it is. If you need to watch it again, you may. That's the end of section 9.4. Please, if you get stuck, please let me know, Google Hangouts, FaceTime, whatever you need to do. I'm happy to go over it with you, okay? I want to make sure you guys are really understanding this because exponents can be really confusing, okay? Call me. Have a good day.